Hi, my name is John again, and we're going to be looking at the product rule today for the derivative. The product rule, let's go over it a little bit more in detail before we start. The function is going to be some product. Product means answer to multiplication of two functions right here. Let's call it little f and little g. So we multiply these two functions, we get this new function called big F of x. Okay, so a lot of students, when they first start off, or when they look for the derivative, remember it's the first derivative, which is going to be the tangential function. They say it's going to look like this: f prime of x, times g prime of x. That is absolutely false. So make sure it's not going to be something like this, where it's f prime of x times g prime of x. Okay. So when we take the derivative of the function of big F, it's a little bit complicated, so make sure you write this down. It's f prime of x times g of x plus g prime of x times f of x. Here's a little shortcut for that. I'm going to write it down: f prime times g plus g prime times f. And so let me write this down a little bit nicer. F prime times g plus g prime times f. I know a lot of teachers, a lot of books, they're going to do something like this: g prime times f plus f prime times g, or sometimes they go like this: f times g prime plus g times f prime. These are all the same things. I want you to memorize it this way. There's a certain reason why I want you to memorize it this way. I'll give you intuition on this. We're going to be using the quotient rule, where f over g is going to be same thing as this: f prime times g minus g prime times f all over g squared. When we, this is called the quotient rule right here. This is called the product rule. You're going to be learning the quotient rule and the product rule at the same time. And I had a really difficult time in high school memorizing the product rule and the quotient rule. And I looked at these and go, well, there's got to be some commonality. So I found a pattern. It's mine. It's all mine. Sometimes the teachers go, low d high minus high d low all over low squared, and off you go. Bunch of crap. I'm sorry, good stuff. Sorry about that. Anyways, you could do the low d high, high d low, where does the low go, where does the high go, etc. If you memorize it this way, the only difference is that you have a plus here and you have a minus here. So once you memorize the product rule this way, the quotient rule becomes extremely easy for you to memorize. Okay? So it's the derivative of the first function times the second plus the derivative of the second function times the first function. Sometimes they write it this way: d over dx of f times g plus the derivative with respect to x of g function, whatever that is, times the f function. Sometimes this is the way a lot of books write it: the derivative of the first times the second plus the derivative of the second times the first. So this means the same thing, this means the same thing, this means the same thing. You memorize it this way, the quotient rule will become a lot more effective, a lot more easier to handle. Okay, so let's start some examples. Example number 1, a real simple example. Let's suppose f of x, sometimes they call it little f right here. Let's rewrite that. Little f of x is equal to x plus 1 times 2x minus 3. There's a real simple function. X plus 1, 2x minus 3. They have little f right there. Since I already have little f, I'm going to rename this big F. That's all you have to do. And what I like to do before I start is actually label this, put a braces, call it f right there, and call this g right there. So there's your f function, here's your g function. And before I even get started with the product rule, the quotient rule, I like to find the derivative. F prime, the derivative of x plus 1. We're going to use the power rule this time. So we're not going to look at the second equation, a second factor at all. We're going to look at the first factor. Derivative of x, as we found earlier, was 1. The derivative of constant is 0. Now let's get g prime. We're not going to look at the first factor. We're going to look at the g function right here, the derivative of 2x. We said the linear, the derivative of the linear function is just 2, and then plus, or minus in this case, the derivative of constant is just 0. So we're just going to leave it as 2. Remember, this is step 0. Make sure you do this portion and this portion first before you actually start. And I always like to write the formula down before I start. It's f prime times g plus g prime times f. What's the derivative of the first? It's 1 times the second times g, which is 2x minus 3, plus the derivative of the second right there, which is just 2 times x plus 1. And we do want to distribute that out and simplify that expression. So you get 2x minus 3 plus 2x plus 2. I'm distributing the 2 out. I end up with 4x minus 1. Okay, that's your answer. Well, let's revisit this one more time. Let's call this big F of x. I'm just going to distribute this out. I get 2x squared, folding it out. Minus 3x plus 2x is minus x, and plus 1 times minus 3 is minus 3. There's your f, big F. Let's take the derivative with respect to of big F of x. Using the power rule, as we learned earlier, bring it on down, subtract 1. It's going to be 4x. The derivative constant, derivative of a linear function is just minus 1. That's the coefficient, and derivative constant is 0. So I end up with 4x minus 1. Oh, look at that. Notice it's not the derivative of the first times the derivative of the second. You just can't distribute that out. It turns out to be that it's a pretty complicated formula, f prime times g plus g prime, the derivative of second times the first. And here we have it. We did it both ways. So the next question you should be asking us, or me, is, why do we have to use this way when it's easier just to distribute this out? Well, when you get into a lot more complicated functions, the product rule is going to really help instead of trying to distribute everything out. Okay, so make sure you use the product rule, and let's do some more examples of the product rule. What's another example that I just did? Oh yes, here's another example. Example 2. Let's say the function looks something like this. 2x squared plus 1 times x cubed plus x. Okay, and so the first step we're already going to do is label that. Let's call this f right there, and let's call this g right there. What's f prime? The derivative of 2x squared is going to be 4x, and then derivative constant is 0. So let's get g prime right here. The derivative of 3x, x cubed. Bring it on down. Subtract 1 on the exponent. 3x squared. The derivative constant is the coefficient, which is just 1. There's a hidden 1 right over there. So let's use the product rule again. F prime of x is going to be f prime times g plus g prime times f. It's a really nice idea, always to write the formula out before you start. You'll automatically memorize it. F prime is going to be 4x times g, which is going to be x cubed plus x, plus g prime, which is going to be 3x squared plus 1, times f, which is going to be 2x squared plus 1. Distribute that out. For the first term, that's the first term, that's the second term. These are called factors right here. 4x to the fourth plus 4x times x is 4x squared plus, I'm going to distribute this out. 3x squared times 2x squared is 6x to the fourth. Distribute this out. 3x squared plus 2x squared is plus 5x squared. It happens to be that the outer and the inner added to like terms. And then last in FOIL is plus 1. 1 times 1 is obviously 1. I'm going to simplify that a little bit further. 4x squared add like terms. 4x to the fourth plus 6x to the fourth is 10x to the fourth. You have a couple of x squares here. 4x squared plus 5x squared is 9x squared, and of course plus 1. That's it, and that should be enough to get you started. I'm actually going to do, before that, it's only been about 10 minutes, so I'm actually going to do one more problem, number 9, one of the other examples, example 3. So the function looks something like this: x squared times x cubed plus 3x squared. Okay, let's see how you do this. Well, we can actually distribute this out, and using the power rule, we can work out the problem, but we're actually going to use the the product rule. First thing we want to do is label this big F so we don't confuse ourselves. Label this F, label this G right there, and we're going to find out F prime. The derivative of x squared is going to be 2x. G prime, the derivative of that is going to be 3x squared plus 6x. Remember the power rule. The first thing we do is bring down the 3, there it is, and then subtract 1 on the exponent, which is going to be 2. Derivative of that, bring it on down, that's 6, and then x to the second minus 1 is x to the first. And again, we're going to use the product rule. F prime of x is equal to f prime times g plus g prime times f. F prime is 2x times g, which is located right here, x cubed plus 3x squared, plus g prime is 3x squared plus 6x times f, which is going to be times x squared. Going to distribute that out. That's going to be 2x to the 4th, and then plus 2 times 3 is 6, x cubed plus x squared times 3x squared is going to be 3x to the 4th plus x times x squared, 6x is going to be 6x cubed, and that becomes, here's like terms, 5x to the 4th. Here's another like term, it's going to be plus 12x cubed. Again, what we could have done in this situation is we could have distributed it out, so we're going to use method 2. You know, write it in here, method 2. Okay. Big F of x, if you distribute that out, is going to be x to the 5th plus 3x to the 4th. I distributed x squared times x cubed is x to the 5th. X squared times 3x squared is going to be 3x to the 4th. Simple way, f prime is equal to, bring it on down, subtract 1, it's going to be 5x to the 4th, plus, drop down the plus sign, x to the 4th times 3 is 12, and subtract 1 and the exponent is cubed. There's your derivative function. Let's see. Oh, same function. 5x to the 4th plus 12x cubed. Notice that we could have used the product rule, or we could have just distributed out and then take the derivative. Either way, you should get the same exact answer. Good luck on your homework, guys. That's the product rule. We look forward to the quotient rule on the next video.